This cross-section shows the 3 distinct strata required for this build: a dense cookie crust at the bottom, a thick, velvety mousse in the center, and a glistening layer of ganache on top. Because we are bypassing the oven entirely, we cannot rely on heat to coagulate eggs and set a liquid batter. Instead, this cake must hold its shape through the careful application of specific structural ingredients. Looking at this inventory, the requirements are strict. You need a spring-form pan, an electric mixer, and precise measurements, specifically 500 grams of cream cheese, 3 teaspoons of gelatin powder, and exactly 1.5 cups of Nutella split between the filling and the topping. The cream cheese itself must be the firm, foil-wrapped block variety. Tub cream cheese is chemically formulated with extra water and stabilizers to make it spreadable. If you use it here, your final cake will collapse. Without the baking process to evaporate excess moisture and hide mistakes, achieving a firm, sliceable dessert requires you to execute these chemical and mechanical steps in a strict sequential order. This diagram illustrates a common failure point. The springform pan's raised inner lip traps the crust, making it impossible to slide the dessert off intact. To solve this, we invert the base, clamping parchment paper over it to create a perfectly flush working surface. With the pan engineered for a clean release, we build the foundation. We mix 200 grams of finely crushed Oreos with exactly 60 grams of melted butter. The creamy filling inside the Oreos provides additional binding power, requiring less butter than a standard graham cracker crust. Once mixed, you must aggressively compact those wet crumbs into the bottom of the pan. Using the flat bottom of a measuring cup, press down firmly to force out any loose air and create a dense brick of cookie. Combining that heavily compressed base with the inverted, lip-free pan guarantees a clean, fracture-free release when it is time to unmold the final dessert. Next, we prepare the primary stabilizing agent, gelatin. We sprinkle 3 teaspoons of gelatin powder evenly over a 1/4 cup of cold water. This process, known as blooming, allows the dry granules to absorb the liquid and swell. After sitting for 5 minutes, the mixture forms a solid mass. We apply a brief 15-second burst of heat in the microwave to transition that solid back into a workable, pourable liquid. While the gelatin cools slightly, we begin the aggressive mixing phase. Using an electric mixer, we beat the block cream cheese, powdered sugar, and a full cup of Nutella until smooth. Then pour in the liquid gelatin and beat it again to fully integrate the stabilizers. In a separate, chilled bowl, we whip 1 cup of cold, heavy cream. The fat molecules in the cold cream trap microscopic pockets of air, expanding the heavy liquid into stiff, self-supporting peaks. This diagram shows why our mechanical approach has to change. An electric mixer uses a violent action that destroys the fragile air pockets we just created. Instead, we use an overarching folding motion, lifting the heavy batter over the whipped cream to preserve the trapped air. We execute this folding sequence in 3 strict stages. By integrating 1/3 of the whipped cream at a time, we gradually lighten the heavy Nutella base without crushing the volume. The liquid gelatin provides the rigid structural scaffolding, while the careful folding preserves the trapped air. Together, they lock the mixture into a velvety, cloud-like mousse that can support its own weight. We pour the mousse mostly the cookie crust and place it in the refrigerator for 1 hour. This initial chill drops the internal temperature just enough to form a semi-solid skin on the surface of the mousse. With that protective barrier established, we prepare the topping. The ganache requires exactly 1/2 cup of heavy cream, 1/2 cup of Nutella, and a 1/4 cup of dark chocolate chips. As seen here, we melt these ingredients together in careful 30-second microwave intervals, stirring between each short burst of heat. This ensures the chocolate fully liquefies without burning or seizing. Once smooth, the ganache is too hot to pour immediately. We leave it at ambient room temperature for exactly 5 minutes to safely lower its thermal state. Pouring the cooled ganache directly onto the chilled mousse, we avoid using a spatula. We simply tilt the pan in a slow circular motion, letting gravity guide the liquid into a perfectly smooth, mirror-like layer. At this stage, the ganache is still in a liquid state. Dropping heavy toasted hazelnuts onto it right now will cause them to sink straight through the surface and ruin the visual finish. By forcing the mousse to form a skin, carefully temping the molten ganache, and delaying the heavy garnishes, we prevent these distinct strata from bleeding into one another. The fully assembled cake now returns to the refrigerator for a minimum of 3 hours. This extended chill brings the entire unit down to a uniform temperature, locking the gelatin matrix and the chocolate ganache into their final solid states. Now we release the springform collar. Taking hold of that parchment paper overhang we installed earlier, we can cleanly slide the cake right off the inverted, lip-free base and onto a serving platter. With the ganache now fully solidified and capable of bearing weight, we place a border of finely chopped toasted hazelnuts around the outer edge of ganache. We complete the plating with precisely piped dollops of whipped cream along the perimeter, finishing with a quick zigzag drizzle of warm, liquid Nutella across the top. Following strict mechanical setups, managing exact thermal states, and respecting the ingredient chemistry yields a flawless bakery-level dessert, all without ever turning on an oven.